Okay, so all of you there, Gauri isn't here. Okay, anyways, and Roni is also not here. Anyways, let us start the class. So in the previous class, we started a new chapter, that is friction. So in the chapter friction, there are different concepts which we are going to be learning. Last class was just an introductory class of the chapter. Okay, so in the chapter friction, we will learn what is friction, how friction is generated, what are the factors that affects friction. In fact, some of the factors we discussed in the previous class right now. Then we'd be learning about different types of frictions, like static frictions. Okay, Gauri is here. We'd be learning about the static friction, sliding friction, rolling friction, and then we'd be learning about fluid friction. Yes, Gauri, how are you? So
Fine, sir.
good. So we'd be learning about different types of frictions and what is the relation between them. Okay, now in terms of increasing order, which friction would be more as compared to other one right now. So we'd be learning about that. Then we would be learning about advantages of frictional force, right? So friction is said to be a necessary evil. Friction is called as necessary evil. So why is it so? What is the reason behind saying friction like it's a necessary evil? Hmm? Then we would be learning about disadvantages of the frictional force, how it is disadvantageous. Okay, now so it has both the sides. There are pros and cons, both related to friction. It is advantageous and it is disadvantageous also. Getting it, guys? Furthermore, we would be learning about how we can increase or decrease the friction. Okay, how you can increase the friction or how you can decrease the friction, right? So we would be learning about that. Okay. Then particularly we would be learning about how wheels reduces the friction and how use of ball bearings used in like different machines like in bicycles or in the fans, it reduces the friction. So you'd be learning about that. Then later on we'd be learning about like friction is not only observed in air and in solid objects. Friction will be observed in the liquid also, in the fluid also, particularly in the water also. Getting it, guys? So particularly we'll be learning about friction in water. Okay, no? So we'll be learning about that also. And then we'll learn about, in the last part of the chapter, we'll learn about how birds, how fishes, how aeroplanes have, like they have a peculiar shape. They have a particular shape. That is, they have a streamlined shape. So how a streamlined shape helps them to retain their energy so that they don't have to spend too much of energy into movement. So just imagine, you guys think about this, like if aeroplanes were to be made of this shape, say the engineers started making aeroplanes like this. So will the aeroplanes move easily? Will it be easy to fly the aeroplanes if it were to be of this shape?
No, sir.
Obviously no, because the air friction will increase, air resistance will increase, right now. So that is something which we learned, that how streamlined shape helps in reducing the friction and how fishes and birds, they are able to save their energy due to the shape that they have. Also, in the image you can see like due to friction heat is also generated. In the chapter combustion and flame, you guys would have, we have learned about this. Okay, now where we learned about the burning of matchstick. Okay. By the way, since this topic came up, now I have one small question to you guys. See, you tell me, nowadays, in the head of the matchstick, do we use the red phosphorus or do we use the white phosphorus? P for phosphorus.
The red.
All of you saying red? Everyone? Yes. So that is correct. Okay, now nowadays red phosphorus is used because white phosphorus is highly unstable chemical. Okay, now so many times it might cause some injury. Okay, now it might misfire and can be injurious. So thereby nowadays red phosphorus is used. Anyways, okay. So talking about friction, we say that friction is basically, this is a force that will come into action, that will come into play whenever two surfaces comes in contact with each other. So there will be friction. Getting it? So any two object lies over one another because of friction and because of other things also. Getting it, guys? So this is a force that will come whenever two surfaces will be in contact with each other. Okay, either the two objects can be both the solid objects, either one of them can be solid, another one can be gaseous, or one of them will be solid, another one will be liquid. Getting it? So basically, whenever surface of two objects will come in contact with each other, friction will come into action, no matter what is the state of the two objects. Either it can be solid, liquid, or air. Getting it? Furthermore, as you can see, this person is trying to push the door. Okay, now? So he is pushing it, but in response to the pushing force, the force of friction is also applying over here, but in the opposite direction. So force of friction always acts in the opposite direction to the motion of the object, or acts in opposite direction to the direction of the force, meaning that the direction in which force will be acting, so friction will always act in a direction opposite to it. Getting it? Okay. Also, it is due to the force of friction that an object will basically oppose the movement. Getting it? Oppose the movement. So it will be due to friction, right? So the force of friction opposes the relative motion between the surfaces of two objects. So why this door is not moving over this object? Because of force of friction. Because this force of friction is opposing the movement. In order to make that object move, you have to apply force of greater magnitude. Okay, now force of greater magnitude, meaning that if force of friction is, let us say, 25 Newton, so this person must have to apply a force greater than 25 Newton. So either it could be 26 Newton, 27 Newton, like that. So
Sir,
hope that
if
is clear.
the person applies 25 Newton same, what will happen?
So in that case, the force will be balanced. Both the force will cancel out each other and the object will not move. Remember, in the chapter force and pressure, we learned about balance and unbalanced force, right now.
Yes, sir.
So in that case, here also 25 Newton force, and the friction force is also 25 Newton. So the net resultant force will be, it would be 25 plus minus 25 Newton. So that is 0. So the object will not move. So the person has to apply a force greater than 25 Newton, for example. Then we learned about factors that can affect the friction. So it will be, basically there are 3 factors that affect frictions. What are they? The first one is the irregularities of the surface, right now, or the regularity of the surface. So if the surfaces are irregular, so thereby the force of friction will be more or less.
So can you repeat?
Can you repeat?
If the irregularity of the surface is more, so then the friction will be less or high.
High.
High, right now. So thereby, if the roughness of the surface is more, so thereby more friction will be generated, right? So for example, you would have observed that it is more harder to walk on a rough road with pebbles than on a smooth, well-leveled road. Like you happen to go to a village, for example. So usually what we observe, the roads of the villages are not very smooth. So it's a rough road now. So this is a very rough road with lots of pebbles in it. And this is a comparatively smooth road. So on the first type of road, it will be difficult for us to walk because of surface roughness, right now. And here the surface is smooth, so thereby it will be easier for us to walk, right now, because of reduced friction. That is one thing. Furthermore, we learned about that if the amount of force that will be acted upon the object, meaning that if you give a small push, so you will experience a low friction. But if you increase the magnitude of the force, increase the magnitude of the push, so thereby friction will also increase. Getting it, guys? So that is one thing. Another way to look at this image is that this is a smooth surface, so thereby friction is low. Low friction is there, So so the person is applying a small push, right now. So friction observed is less. While on a rough surface, in order to move the object, we have to apply force of higher magnitude. Okay, now more force needs to be applied so that this object moves, right now. But friction will also be more. Getting it, guys? So on a smooth surface, the force of friction will be less. On a rough surface, force of friction will be high. That is one thing. Furthermore, there's one more thing we can think of it over here. Like the weight of the object can also be taken into consideration. Getting it, guys? Like basically try to understand it in this manner. Like you're having two objects, like this object and this object. This one weighs 100 kilogram and this one weighs 50 kilogram. This one weighs 50 kilogram. And let us say that the area of the surface area of both, so the area of contact is same. This area and this area, let us say both of them are of equal length. So although the surface area is equal, but in which one the force of friction will be greater? In the first or second?
First one.
First one. Getting it? So thereby the weight of the object will also determine the friction. So there's one more factor which we can count over here. That is the weight of. We haven't gone to that topic right now. Okay, no. So weight of the object, that also determines friction. Okay, so it will be directly proportional right now. So weight will be I mean to say friction will be directly proportional to weight of object. Getting it?
Yes, sir.
Directly proportional to weight of object. Higher the weight, higher will be the friction generated. So that is something which we have done. So this topic was small and it has been completed. Okay, now next you would be learning about types of frictions. So talking about types of frictions, namely we have 4 types of frictions right now. You have static friction, sliding friction, rolling friction, and then you have fluid friction. Fluid friction is not mentioned over here, but there is one more, that is fluid friction. Okay, now let us learn about them one by one. Talking about the static friction. So the static friction is the frictional force that will come into action, or that will come into play until an object starts to move. So while an object is not moving, so the friction that is generated at that time, it will be called as static friction. Like this boy is trying to move this box. So, but the box, it has acquired a position of rest. It is not changing its position. So this boy is applying some push on this, pushing it. But there is a friction also over here. Frictional force is also acting upon it. Let us say he is applying a force of, let us say, 50 Newton, and thereby the frictional force generated is, let's say, 80 Newton. So at that moment, the friction that is generated in this situation is called as static friction, because this type of friction is not allowing the object to move, because it is higher than the force applied by this person. Getting it, everyone?
Yes, sir.
Okay, now. So in order to move this object, the person has to apply a friction with a magnitude greater than 80 Newton. Okay, now. So hope you guys are getting it. Okay, now. So let me just write a small definition for this. So it is the type of friction that comes into play until an object starts moving. So until an object starts moving. So see, now in the second case, let us say this was case A. In the second case, let us say that the boy is applying a force of 79 Newton. Will the object move?
No, sir.
No. In the third case, will the object move? Let us say 80 Newton. Will the object move?
No, sir.
No. So he has to apply a force greater than 80 Newton, that is 81 Newton, let us say. Getting it? So out of all this friction, all these magnitudes, so what will be the magnitude of static friction? It will be 80 Newton, right now. So this is the force of friction that was existing just before the object started to move. Meaning that when you applied a push of 81 Newton, when you pushed it with a magnitude of 81 Newton, so thereby it started to move. But before that you had applied 80 Newton also. So at 80 Newton, the object was not moving. So that is the magnitude of static friction. What is it? This is magnitude of static frictional force. So this is that force which was existing just before the object started to move. So hope this concept is clear to everyone. If anyone has any doubt, please let me know.
No, sir.
No, sir.
Good. Furthermore, another important thing, make sure whenever you write the definition of this, write down this point also, that an object must overcome the static frictional force in order to start moving. So as you have seen, the person applied a force of 81 Newton in order to make this object move. So force greater than static friction has to be applied to make an object move. Got this, everyone? Okay, next topic we would be learning about is the sliding friction. Okay, now, so talking about sliding friction, okay, by the way, this sliding friction, many times it is also called as kinetic friction. Okay, now this is the another name of sliding friction, okay, called as kinetic friction. See, kinetic, the word kinetic now, it is used whenever something is in motion. Yeah, Shikrika. See, do let me know once you have taken the screenshot or noted it down, Shikrika. Done?
Yes.
Okay. Yeah. See, talking about sliding friction. So I say that it is also called as kinetic friction. Why? Because see, kinetic is the type of it's a word. It will be used whenever an object will be in motion now, whether it be a car, whether it be a bicycle, whether it be a train, whether it be even the molecules of a given substance. So if they are in motion, if anything shows some movement, so thereby we say that they are kinetic objects or they are having a kinetic energy. So in the case of sliding friction or kinetic friction, the object starts to move. The object starts to move. So that's why it is called a sliding friction. Okay, no? That's why the another term kinetic is also used over here. Have you understood why it is also called as kinetic friction?
Yes, sir.
Okay. Furthermore, whenever an object would be sliding over another object, so thereby it's not like you will be able to slide it very easily. Some resistance will be observed here. Okay, now we will experience some resistance. So the force of resistance that will exist between two objects when one object is slided over another, right now. So that is called a sliding friction. Okay, now, or basically we say that sliding friction would be the kind of sliding frictional force is the force that we require to slide one object over another object. Getting it now? So hope you guys are getting it. And we have several daily life examples of this sliding friction. Okay, we have several examples of this. For example, what do we call this? like forgetting the name of this stair, like in the playground it is there, particularly in the schools.
Slide.
Yeah, the
Slides.
slides, yeah, basically the slides right now. So there, what kind of friction you will experience? Sliding friction, no? As the boy is sliding over the slide, getting it? So that is one example of sliding friction. Okay, so hope you guys are getting this. So hereby, what we have learned about sliding friction, that it comes into action, it comes into play whenever an object will be moving along the surface of another object. It will be basically sliding over another object. So the type of friction that will exist at that time will be called as sliding friction. Okay, now, or we say that it's the type of friction that is opposing the sliding of one object over another. Okay, now, so as this boy is trying to slide this almirah over the ground, so he is able to move it. This is moving, but with some resistance also. So the ground will be resisting. The ground resists the movement. Ground resists the movement. So ground basically offers friction now. Friction is generated over here, right? So sliding friction is that kind of friction. It's that type of friction which will be generated whenever one object is sliding over the another object. So hope this topic is clear to everyone. If anyone has doubt in this, please let me know.
No.
Okay, so when will it come into existence? When will it come into existence? Whenever one object would be sliding over the another object. Okay, now it comes into existence whenever an object slides over another object. All right, now over another object. Furthermore, this will be offering some resistance also. Okay, now, so this friction, this sliding friction opposes the movement, opposes the movement of sliding, movement of slide of an object. Getting it? Although this is offering some resistance, it is opposing, but it is not strong enough to stop the object. Now try to understand this thing. Earlier we had studied about static friction, where the object was not moving now. In the case number 1, what did we learn, guys? When it was at a position of rest, so the type of friction generated was?
Sliding.
So that was static friction. But from rest,
I didn't hear the question.
yes, when it started to move, so thereby at that time, let me draw a surface of some object, like this is another object over which it is sliding. So at that time, the kind of friction that was generated between the surface of these two objects, that was then sliding friction. Hope you have understood this. We have a common example of slide over here. Okay. Now, Nick, let us learn about the rolling friction. Okay. With the help of this bicycle, you can get an idea about the rolling friction. Here, the wheel of the bicycle is basically rolling over the road, rolling of the surface, right now. So whenever an object rolls over another object, then rolling friction comes into existence. Getting it? So it's a type of friction, a type of friction that comes into play into play whenever a round object, like we can example of wheel or ball, or you can take example of any other objects like a cylinder. So whenever any round objects would be rolling freely over a surface. So a type of friction that comes into play whenever a round object like wheel, ball, or cylinder rolls freely over a given surface, over a given surface. Got this so far? Also, you guys tell me, like in this example, let us say this is the surface of a road. Now you guys tell me the area in contact with the road, the area of the wheel that is in contact with the road, it is very less, right? It is very less now. Now imagine what is the problem if the vehicles were to be made of this shape. Why can't vehicles, the wheels of the vehicles be made of this shape? What would be the problem?
More friction.
Friction
Can
is
move
more.
so smoothly.
Okay. Why friction is more? Why friction is more?
Cause sliding friction is like greater than the rolling friction.
Here sliding friction is coming into existence, or the basic reason is related to the area in contact, the surface area. The area in contact is more, no? The area in contact is more. So that is why the vehicles, the wheels of the vehicles are not made of this shape. So you can easily tell this thing to me that the magnitude of rolling friction will be minimum than the static and sliding friction, right? Okay, no? So that is what rolling friction is. It's the also see, this will be resisting, offering some resistance. That is why eventually after some time this bicycle, if you stop pedaling, will come into the position of rest. So it offers some resistance, although it will be less, but it offers some resistance. So is that clear to everyone? A very basic concept. Okay. What are the examples? Examples are wheels of bicycle, or skateboards also. Skateboards. Furthermore,
Skating shoes.
repeat again.
Skating shoes.
Please speak a little bit clearer.
Skating shoes.
Yeah, skating shoes. Yeah, that also. Okay. Ball bearings also. Okay, no? Ball bearings also. I guess I had one image of that, like over here. This one over here. See, the ball bearings. Okay, now. So they also help in reducing the frictions. They are also basically working on the concept of rolling friction, because rolling friction is the friction generated with round objects is minimum. That's why ball bearings would be used in the different kind of vehicles, different machines. Okay. So hope you guys have understood this. If there's any confusion in this, please let me know. Next, you'd be learning about the fluid friction. So talking about the, yes, yeah. Chikrika, were you saying something?
I was asking if you could go to the previous.
Oh, okay, okay.
Yes.
Good. Talking about the fluid friction. So whenever an object would be moving in a fluid here refers to both air and water. Keep that in mind. Fluid refers to both air and water. It is not specifically only referred to water, both air and water. Okay. So whenever an object would be moving in a fluid, like moving in a water body, moving in the air, so it will also experience some resistance. Okay, now it will also experience some resistance while moving in that medium. Like whenever aeroplane will be moving in the air, so it will experience air friction. Getting it? So we would be learning about that. Or further, like whenever an object would be moving in the water body, so thereby also it will experience some friction. That friction will be particularly called as viscous friction. That will be called as viscous friction. So the fluid friction in the water, we also call this as viscous friction. So talking about fluid friction, so whenever an object moves in a fluid, fluid is air and water, air or water. So whenever an object moves in a fluid, the fluid exerts a friction. We call that as fluid friction. So the fluid will be exerting a fluid friction upon the object, upon the object. That is one thing. Okay, now furthermore, when this takes place in air, so then it will be called as air friction. So we have examples of aeroplanes, birds, rockets, etc. Furthermore, when we talk in the case of water, so there the fluid friction will be called as viscous friction. Viscous friction. Swimmer, sea divers, fishes. Now, one particular thing we observe that in order to reduce this fluid friction, whenever the object moving in the air or water, whenever they experience the fluid friction, so in order to reduce the friction, the shape of the body will be having a streamlined shape. Okay, now they will be having a streamlined shape in order to reduce the friction and in order to save the energy and be able to move freely in that medium. So to avoid fluid friction, won't be proper to say avoid, but it would be proper to say to reduce. So to reduce fluid friction, objects have or organisms have a streamlined shape. So a streamlined shape body would be a body where the front part of the body would be made pointy so that the contact area of the front part of the body is reduced with air. So thereby, streamlined shapes of the body helps in reducing the fluid friction. Hope you guys have understood this. Okay. Any questions from this topic?
No, sir.
So the streamlined shape will be minimizing the air or water resistance. Right now, thereby the design of the airplanes, design of the ships, designs like in the nature we have living organisms like fishes, other organisms that have a streamlined shape that reduces the friction. Okay, now talking about in the increasing order, the talking about the magnitude of different frictions in the increasing order. So as we learned in the case of static friction, the object does not move at all. It does not move, so thereby the friction of static friction is having a maximum magnitude. Then after this, sliding friction and rolling friction. So in the increasing order of their magnitude, the friction which with least magnitude or the friction with least magnitude is rolling friction. After this, sliding friction and then static friction. So friction in the increasing order. This is the friction in the increasing order. So hope that is clear. Like you have an object of round shape, so thereby surface area, area of contact is very less, and also that is example of rolling friction. In the sliding friction, the object will be moving, but it will experience some friction. But in the case of static friction, the magnitude of friction is so much so that the object does not move. It remains at a position of rest. So that is something which we have learned. Now let us learn about what are the advantages of frictional force. First of all, you guys tell me. You guys tell me about the advantages of frictional force.
We are able to like move, stand, and walk.
Good.
And vehicles are able to like move on the road because of the friction between road and the vehicle tires.
Good. And what else? Others also answer. Everyone.
Sir, can you repeat the question?
The question is, what are the advantages of frictional force?
We are able to write and draw on the paper.
Very good.
Sir, be able to walk.
Good. It increases the grip, right? Increases our grip. And what else? Due to friction, the heat is generated, right now. Due to friction, heat is generated. That is why we are able to burn a matchstick. So there are different advantages of frictional force. We are able to walk because of the friction between the sole of our shoe or slipper and between the ground. Because of a friction between the sole of the shoe and the ground. So thereby it stops us from slipping. If there were to be no friction between the sole of our shoes and the ground, so thereby we will not be able to walk. We will basically slip. So thereby we know that the sole of the slippers are made rough. They are made rough on purpose. So thereby thereby the friction between the ground and our sole is maintained, and we do not slip while walking on the road. So many times if the sole becomes very smooth, so many times you will slip on the ground. Right now, might have happened with some of you. If it tears off, if it becomes very smooth, so you will slip on the ground. So thereby the friction is necessary. That is one advantage of friction. The very first advantage of friction is that it is necessary for us to walk. Okay. Some of you mentioned in order to draw something, like now you won't be able to write if there were to be no friction. So that can also be taken as one such advantage. Getting it? Okay. Think about this, that if there were to be no friction existing between the vehicles, between the tires and the road, so will it be easier for us to drive on the road? The brakes will not be applied properly. Even if the brakes are applied, if the friction between the wheel and the road is very less, so thereby it will kind of slip on the road. That will lead to accidents. Getting it? So in that also it is important. So vehicles, particularly to apply brakes on the vehicles, friction is necessary. Okay, now so it is necessary there also. And look at the second image. Why is the shoes of the cricket players or the football players have spikes in it? Is it to hurt someone or is it for other reasons?
To increase the friction.
To increase the friction or to increase the grip, basically, right now? To increase the grip, to increase grip, or basically we should say gives grip. right now. Otherwise, they would be slipping on the playground, right now. So it allows, it increases the grip between the objects. By increasing the friction, grip between the object is increased. Thereby, we are able to walk or run properly on the playground as well, right now. That is one thing. Furthermore, friction generates heat, right now. Friction generates heat. So see, generation of heat, it can be advantages and disadvantages both, depending upon how much of heat is generated and for what purpose friction in this sense is being used. So friction generates heat. So we have examples of burning a matchstick. So thereby we have learned, like whenever you rub the matchstick on the matchbox, so thereby due to friction, heat is generated and red phosphorus ignites, and some of the red phosphorus converts into white phosphorus, and that generates enough amount of heat to burn the wooden stick to burn the wooden stick. Getting it, everyone? So that is another advantage of friction. Okay, no? So we are able to walk on the surface of the earth because of friction. We are able to write, we are able to write with a pen on a surface of paper because of friction. Do tell me, if there were to be no friction, will we be able to fix a nail in the wall? If there were to be no friction, basically that nail will come out of it and slip. The reason why a iron nail sticks into the wall and it is able to like you can it is able to hold on to heavy objects as well. So why? Because of the friction. Getting it? So these are the sand or cement particles. So because of friction, it fixes into the wall. Getting it, everyone? Now, so fixing a nail in a wall. So there also friction is acting. So that is also one advantage of friction. So it allows you to fix a nail in the wall. Okay, now furthermore, you guys tell me, if there were to be no friction between the objects, will an object ever come to a state of rest? Let me repeat. Will an object come to rest if there is no friction? Suppose you have hit a ball in a playground, and if there is no friction will exist between the ball and the playground. So will that come to a position of rest?
No, sir.
Practically no. Getting it, guys? So it is important that an object comes to a state of rest. Frictional force is necessary. Right now. Furthermore, you guys tell me, like every building that you see around us, every building that you see around yourself, like a frictional force is acting between the different bricks, different parts of the building. That is why that building is existing in a stable state. It is standing upright. If there were to be no friction, so will it not collapse? Yes, Chakrika, Khadija, Alif, Gauri. Will
Yes,
we
sir.
be able to construct the buildings without the frictional force? No. Getting it now? So it's not like there are peoples who are holding on that building. It's not like if we have some people who are holding on the walls of the building and stabilizing it. It's not like that, no. The building stands on its own once it has been constructed. Why? Because frictional force acts between the different parts of the building. So buildings won't be able to, we won't be able to construct buildings without frictional force. Okay. Now, I want all of you to imagine about this. Like, will life on Earth exist without frictional force? I'm not exaggerating, but just asking a practical question. That think about this. that will life exist without friction? What could be really difficult? What can go wrong? Can we live normally without friction? Yes.
No, sir.
Everyone think about this. Basically, if our world were to have no friction, if there is no friction, we won't be able to hold on to anything. We won't be able to hold on to everything, huh? Okay. By the way, if you guys were to we have fingerprints right now. We have fingerprints, right? So, what is the advantage of having fingerprints? Think about this. What is the advantage of fingerprints? Think about this. All, not think of it in that significance. No? Like it gives you a unique identity. Uh, not in that sense. Like every person have different fingerprints and they have a unique identity. I'm asking you guys to think in this perspective. Like, will you be able to grasp onto things easily if all the fingerprints in your palm were to be erased?
No.
It will be very difficult for us now to hold on to things. The things will start to slip from our hand right now. So the fingerprints that you see on your hand, that is also because of some purpose right now. So the every part in our body have some use. Getting it? Okay. By the way, recently I happened to saw a video. There was a person who had no fingerprints. He was suffering from a rare disease which basically leads to loss of fingerprints. Basically, there were no fingerprints on his palm. Okay. Anyways, so coming back to the question which I asked you guys, like, what would happen if there were to be no friction? So, as we know, friction is one of it's a that type of force now, which basically allows us to hold on to different things. So, for example, it would be really difficult for us to carry out day-to-day activity. We won't be able to walk properly. We won't be able to ride the bicycle or take a car or a bus. No machines would be working because of friction. The machines will stop to work right now because all the machines are working because of friction between them. So we won't be able to do any of the activity, hence life would be near to impossible. Got this, everyone? So hope you guys have understood this. Then talking about what are the disadvantages of frictional force. So yes, you guys think about this. What could be the disadvantage of frictional force? Yes, let us start one by one. Starting from Khadija. Khadija, you at least mentioned three disadvantages. At least three disadvantages of frictional force. Okay. Or anyone else? Everyone have to give three disadvantages. Starting from Khadija. Okay, then let's start from Gauri. You.
So friction cause like wear and the tear of the object that are rubbing against each other.
Good.
And then like various movable parts of vehicles generate heat, and like this heat is unwanted and can cause the damage of vehicle machine parts.
Very good. Because you have mentioned two. And okay, that's good. Chakrika, you.
Slows down motion.
Chakrika, your voice is it's not coming clear.
So friction slows down motion.
Yeah, it slows down the motion. Good.
It damages, basically, it reduces the efficiency of a machine.
Okay, it reduces the efficiency of the machine. Very good. Basically, machine will slow down right now because of friction. That's why we have to put oil and grease into the machines for its efficiency. Okay, good point. And
And
like in the image also, you can look.
vehicles may also be damaged.
Braking.
The tires of a vehicle
Yeah. The tires of the
also
vehicles.
be
So
damaged.
that will be damaged. Okay, good. Okay, good.
Yes.
Okay, Alif, you also mentioned some of the disadvantages.
Sir, Lect doesn't work brake in vehicles.
Yes.
Does not work brakes in vehicles.
Okay. So it will be hard to apply brakes if the friction, if the vehicles, they are the vehicles. I mean to say the tires of the vehicles, if they are rubbed off, if they are not proper, so thereby it will be difficult to apply brakes. Good. Did anyone thought about this? Like you have to the consumption of the fuel will also increase if the parts of the machines of the vehicles of the cars are experiencing friction. If the friction increases, so thereby more amount of fuel will be consumed right now. Also, as we know that the aeroplane, as it will be coming into friction with air, so that will produce sound now. The friction will produce sound also. Getting it? So there are different disadvantages of friction. Friction produces heat. It leads to wear and tear. It slows down the motion of the object. It increases the consumption of the fuel. It reduces the efficiency of the machine right now. So all those are the disadvantages of friction. Hope you guys are getting it. Okay, now. So from here, we'll be continuing in the next class. If you guys have any other questions from whatever topic we have discussed so far, please let me know.
No doubt,
Yes,
sir.
no doubts. Okay, I'm going to ask some questions then. Do tell me, out of the static friction, sliding friction, and rolling friction, the magnitude of which one will be maximum?
Static.
Sliding.
No, it's
Sir,
static. It's static friction. No, when the object will not be moving, so thereby the magnitude will be maximum. No.
Okay, sir.
Okay, good. Now, do tell me, what are the factors that impacts the friction?
Peculiarities of the surface.
Okay, and